All right, here we have our torque problem. So Mabel and I think Maud, is that her name? Maud are seesawing on the school playground and decide to see if they can move to the correct location to make the seesaw balance. Mabel weighs 400 newtons and she sits 2 meters from the fulcrum of the seesaw. Where should 450 newton Maud sit to balance the seesaw? Okay, so let's head on over to a whiteboard and write down what we know. So we have Mabel, put Mabe equals 400 newtons, and so 400 newtons, and then it's sitting 2 meters from the fulcrum. Maud is 450 newtons, and we don't know her distance. And you can get their newtons from their weight times the force of gravity, which is 9.8. So just multiply their weight times 9.8. So whatever 400 divided by 9.8 is Mabel's weight, and whatever 450 divided by 9.8 is Maud's weight. So let's make a quick force diagram. So here's our seesaw. We'll see here, we'll see here, but one's not necessarily sitting. So here is 2 meters from the fulcrum, which is where it is, and in this case it is the center of mass. The fulcrum is also the center of mass because the seesaw is an equally distributed, so it's right in the middle. And 400 newtons. And then somewhere, we don't know the distance, somewhere around here, we're just going to put it here, is 450 newtons. So to get Maud's distance, we have to use the equation F times D equals F times D. So we can put in Mabel's stuff first. So 400 times 2 equals, now we put in what we have for Maud is 450 times D. So now what we can do is just times 400 by 2, which is 800, and that equals whatever 450 times D is. And to get D, we're going to have to divide 800 by 450. So whatever this is her distance. So we can bring up a quick calculator. Okay, so 800 divided by 450 equals 1.77 repeating. And we want, for sig figs, 2 sig figs. So we're going to say 1.8 D equals 1.8 meters. That is where Maud needs to be sitting away from the fulcrum, 1.8 meters from the fulcrum, to balance the seesaw out to be equal with Mabel. That is it. Thank you.